Hello, it's Stu from Group 3, question number 3. We are asked to solve a recurrent relation using a retrieve substitution technique. The retrieval method involves a substituting term of a sequence by expanding or reiterating the recurrent relation as the sum of the term dependent on n and the initial condition. We have our initial condition here on the right side, and we can solve the given problems as follows. So our first equation is the initial condition, which is t of n is equal to t of n over 2 plus n. And when n is equal to n over 2, the initial condition becomes as follows. T of n is equal to t of n over 4 plus n over 2 plus n. Solving this equation, we have t of n is equal to t of n over 4 plus 3 times n over 2. We call it equation 2. Again, when n is equal to 1 over 2, the initial condition from the equation 2 become n of 2 is equal to t of n over 8 plus t of n over 4. And again, we substitute this equation back to the second condition in equation 2 to the initial condition on equation 2. So it becomes this part here, and we're gonna add 3 times n over 2 to it. So the entire equation becomes t of n over 8 plus 7 times n over 4, and that's the third equation. So the process can continue until we reach the best case of t of n, and therefore we have t of n is equal to the summation of k, that the number of time we have to just go, which is equal to the big O minus 1n over 2k over 2 to the power of k. If we simplify this equation, we can come to the conclusion that the recurrent relation is actually a big O(n). So the solution is big O, and that's what the question is asking about. So if you want to go further and see the simplification of this equation here, you can take a look on the right side of the screen and you can see the solution right there. Thank you.